Hello everyone. So in this video we will be discussing our next topic, that is exponential distribution. So a continuous random variable x is said to follow exponential distribution with parameters lambda greater than 0 if its probability density function is given by fx is equals to lambda e to the power minus lambda x, where x is greater than equal to 0, and if 0 if otherwise for the other values of x, that is x less than 0. But note, there's a thing to note, that fx is always greater than equals to 0. So the mean of exponential distribution is 1 by lambda, and the variance of exponential distribution is 1 by lambda square. Moving on to an example, it is given that the mileage which car owner gets with certain kind of radial tire is a random variable which is having an exponential distribution with mean as 40,000 kilometer. So mean was 1 by lambda, so 1 by lambda is given as 40,000 kilometer. Now we need to find the probability that one of these tires will last at least 20,000 kilometer and at the most 30,000 kilometer. So it is given that it follows a exponential distribution with the parameter as lambda, and 1 by lambda is given as 40,000. So we can say that lambda is 1 by 40,000, and we know that the probability density function is given by this formula. So now we need to find the probability of at least 20,000 kilometer, which means that probability of x greater than equals to 20,000. And so as we put it in the formula and we integrate it using dx from 20,000 to infinity, we get the value as 0.6065. Now moving to the other part, which was at the most 30,000 kilometer, which means that p is x less than equals to 30,000. So we can calculate it from 0 to 30,000, since x is always greater than equal to 0, and we put it in the formula and we integrate it. So and at the last we get the value as 0.5270. As an exercise, there's a question which in which it said that the time in hours required to repair a machine is exponentially distributed with lambda equals to 1 by 2. So here mean is given as mean that is inverse of mean, that is 1 by lambda's inverse is lambda is given as 1 by 2. So what is the probability that the repair time exceeds 2 hours? If we let x denote the let x be the random variable which denotes the time required to repair a machine, which follows the exponential distribution with parameter lambda. So we need to find the probability of x greater than 2. So we'll find and we will get back the answers. Thank you.